Okay, so basically, we're gonna go back to where we stopped. We talked about the different TCP/IP protocols, and basically we discussed the DNS and DHCP. What we're going to talk about today, we're going to start with what's called file transfer protocol. File transfer protocol actually was very popular maybe in the 90s, something like that. Now it's not that popular. Not so many people use it. Basically, in the 90s, if you wanted to share a database or a data set with another colleague, the FTP was basically the way to do that. Okay, so it wasn't like today where you can actually have a secure server and you can have a login and things of that sort, and basically can use the web browser to access the data from any website. FTP was very common because it was very convenient, first of all, and it can be used from terminals that don't have graphics. So basically, you would use the FTP. Basically, if you just go and use FTP on Windows command line, basically it's going to work. Basically, if you have, for example, ftp.kspace.org, it will actually give you a login, basically, without having to have a user interface. Okay, but actually today, because of the convenience of having a graphical user interface like this, it's very common to use, instead of using the command line to access FTP sites, it's common to use what's called Ftp Client. It's like a software that you can use to log into an FTP server and basically upload or download files from there. So basically, it's like you have a server or you have certain files, and these files can be accessed by many people, okay? And basically, you grant these people credentials, like username and password, okay? Or you can actually have an anonymous login. Anonymous means that you just say that I'm not one of the credentialed users, I'm an anonymous user. So basically, it would allow you to see certain things, but not all of the contents or all the files that are available on that server. So basically, you can control that FTP server to place files there, and you can actually make an area where anonymous users can access certain files and where other users can access other files. And you can actually, for each one of the users, actually you assign a certain place where they can go. Basically, if I log in as Yasser, for example, basically I would access a directory that is assigned to me. If you log in as Ahmed or Muhammad or whatever, you will access another place, basically, if you want to. Basically, it will basically assign for each one of the users a certain entry point. But at the end, it's a file transfer protocol. Basically, you can put in files, you can upload or download files, basically. You can put files there, or you can download files from there, okay? So if you remember, basically, if you access any website, you usually have HTTP at the beginning. For FTP sites or for FTP servers, you start with FTP, basically, okay? So basically, instead of HTTP, FTP protocol actually start with FTP. Sometimes some browsers actually would allow you to access the FTP through the browser itself. So basically, if you have an FTP server, you can basically put it there on the address place of the browser. It can access the FTP site from there. You can access the login. Basically, you give you the login, and whenever you log in, basically you can access whatever. If you have credentials, you would access whatever files that are assigned to you, or if you are an anonymous user, you can basically access the location, the public part of the FTP server where everybody without credentials can access. Okay, so basically it's very convenient to transfer files. You don't really have anything but put files and get files from there. Okay, now it's much more convenient to use an FTP client. What I use actually is an FTP client here. What I use personally is a file called FileZilla. It's one of the very popular FTP clients. And it allows you actually to, for me actually, I use it to upload files on my web page. Okay, so basically, if you want to have a web server somewhere, if you're hosting your web server on an international server, you cannot access it directly. You cannot have a USB file, or basically cannot create the files directly there. You have to actually create the files on your computer and basically upload them there. So basically, I use FTP. So I create my website on my computer and then upload everything over there using FTP. It's very convenient. Okay, so basically this is a really nice, basically this is the main application that people use now. Before, if I wanted to share a data set with a colleague, FTP was the way to go. I would put it on my host or my university FTP server, and basically I would assign it a certain credentials or a certain security, basically so that only the person I wanted, wanted him to access the that data set would actually access it, but anybody else cannot do that. Okay, so this is really very convenient and very nice. Okay, now people do it other ways, but still you can do it this way. Okay, so as I was saying, the FTP servers can be configured to allow unauthenticated users, meaning that I don't have to authenticate. I just say that the username is anonymous. When it's anonymous, it means that I don't have credentials. So basically, it doesn't ask you for a password, and it would basically grant you entry to a certain location that is actually assigned to public users. It's not really, basically, it's a set of files that are accessible by anybody else, okay? Not the credentialed users. So basically, this is called anonymous FTP, and sometimes you call it blind FTP. One of the things that I'm going to ask you to do in the project is to use an FTP protocol. Basically, I'm going to give instructions on how to do that. I'm going to create an FTP server on my own website, and I will give you credentials, basically username and password, and I will basically ask you to download file from there and upload file there. Okay, so basically you're going to download a file from the FTP server that I'm going to place on my own website. And basically, you're going to basically add your own, or basically create a file with your own credentials, your own name and university ID, and basically upload it there, and that's it. But once you do that, you're going to be able to use FTP for any other purpose. Okay? So basically, this is very important. And I actually got feedback, a very good feedback actually from one of you that the networking part is not very well understood by many. Networking is not a theoretical topic, basically, it's practical topic. So the only way to understand networking is to practice, basically. What I'm going to do in the project, which inshallah I will post it for you this weekend, basically it's going to have steps. And basically, when you follow these steps, you will be able to do the things that I want you to learn about networking. Okay? If you have any problems, you can ask me and I can walk you through them. Okay? Once you do that project, you will be able to basically do all the things that we talked about in networking. One very important protocol is wireless protocol. Basically, this is what we all use at home with our routers, our wireless routers. So basically, wireless data communication basically is now replacing the need to be tethered by cable. Basically, you don't have to connect your laptop by a cable to your router. You don't have to do that. So basically, it's very convenient. Imagine also that you are in a hospital and you want to set up or change the location of a certain medical device, okay, that is connected to the internet or connected to the hospital network. If this device, basically, if you have to connect this device through a wired network, then you will have to actually rewire things in order for you to be able to move it. You have to actually, whenever you create a new place for this device, you have to actually make sure that you have a cable access through that other location. And this can be basically, this usually whenever you have to extend wires that go everywhere in the hospital, this is actually problematic. So basically, wireless data communication is very convenient because basically you can access it from anywhere. So the whole hospital can be connected via wireless network without having to have cables running through all the walls of every room in the hospital. Okay, so wireless communication has made mobility possible to a degree never before possible or really even imagined, whereby user can access the same resources standing on the street corner or walking across college campus, and they can while sitting at the desk. So basically, if you imagine that you are a doctor in a hospital, for example, you have your laptop and you're accessing the cases or whatever, and basically you're doing your work from a certain location, for a certain office. If you want to go to the restaurant, for example, or if you want to go to another room, for example, you can still do the same thing from any place in the hospital. Okay, so basically it's very convenient. Mobility is actually sometimes very convenient for people to basically have available. So basically, when we talked about wireless networking, basically we started first with wireless voice communication like mobile phones, which basically originated in the 1990s, which actually revolutionized things in the 1990s. Wireless data communication actually became more dominant or more prominent started from the 2000s, basically, early in the 21st century. So basically, wireless data communication has become very much the standard in all home routers. Before, you would actually have to connect your computers to basically a modem or whatever inside the home. Basically, if you want to have access, basically you have to extend a cable, an Ethernet cable between that modem and your computer. Now you don't have to do that. The success, of wireless local area networks, basically is basically attributed to one of the very important things that they started with, which were standards. Basically, standards. They started with a very solid set of standards. Basically, the wireless LAN standards are basically collectively called IEEE 8211. It's pronounced like this: IEEE 8211. Okay. This is basically the umbrella standard for all the wireless network standards. But actually, there are variants of it, and they are still basically developing more capabilities, because basically the same, or basically the wireless networks that was available in the 2000s is very different from what we have now. For example, the first version, which was 8211A, it was released in 1999. Basically, the frequency of communication is 5 gigahertz. The maximum data rate was 54 megabit per second. B, you have a little bit less. Basically, it's 2.4 gigahertz. Basically, it was 11 megabit per second, but actually it was a little bit more convenient for some applications. If you look at what we have now, for example, here, if you look at the N, for example, the N became available in 2009. You're talking about 600 megabits per second. Okay. Now, if you have connectivity, if you have, for example, a STC router at home, now they have a dual band router. Okay. What the dual band? Basically, you have two networks. Basically, one of them is usually at 2.4 giga, and the other one is at 5 giga. Okay, and basically the 2.4 giga usually has a limit. The limit is usually it's like 54 megabits per second. Here the limit is much higher than that, basically. So for example, if you have a connection that is 200 megabits per second, okay, megabits per second, okay, not bytes, megabits per second. Basically, you have to, if you want to reach that 200, basically you have to connect through the 5G. Okay, 5 gigahertz, not the 2.4 gigahertz. Okay, so basically, it's very important to understand the difference between these two. Okay, usually, if you have a router, if you have one of the newer routers of STC, if you have a 100 megabits per second or higher than that, like 200 or now 300, you usually have two wireless access points. One of them for the 2.4G and the other one is for the 5G. Basically, you can connect to any one of them, but you know that the limitations for this one here is basically 54. Here you can reach much higher than that. The advantage of the lower frequency of transmission is that it can actually reach further. Basically, the coverage area will be larger. But the 5G is much faster, but the coverage area is a little bit smaller. Okay, so basically you have to basically kind of try to basically see which one of them. Basically, if you need coverage, basically you have to have 2.4G. If you want to have speed and you don't worry about the coverage, you're close to the modem or the router, basically you can use the 5G. Okay. So basically, if you want to talk about the different aspects of the different standards, you talk about difference in speed, coverage. Basically, and usually these standards actually, they target very high speed communication, the target wide coverage area, the try to reduce interference, and basically you have to have a very strong level of wireless security. This is very important. Security means that you're not sending everything on the air and anybody can listen. Basically, you're sending everything encrypted so that basically if somebody is eavesdropping, he's not going to understand what you're sending. If you're sending usernames and passwords and things of that sort, critical information like your banking information, you're not going to be able, or basically the hacker will not be able to access such information. Okay, so here for the wireless protocols, remember that if you have dual band, the 2.4G would allow you a wider coverage but less speed. Okay, the maximum speed is a little bit less. For the 5G, you have lower or basically smaller coverage and much higher speeds. If you have any questions, please stop me at any time. Okay. One other protocol, basically this might not be very useful, but actually it sometimes can be useful, but it's basic for specialized users a little bit. It's not like a common thing that people use like the FTP or wireless networks or things of that sort. It's not like that, or the other DNS and things of that sort. It's called Remote Desktop Protocol, okay? Let me tell you how I use this, basically, what I use this for. Basically, I have a computer that, a laptop that I have Linux installed on it. You know that Linux is an operating system, basically. Some applications actually run on Linux, so basically I like to have a Linux machine around, okay? So my problem was that I have a desktop, and the desktop is connected to a much nicer monitor, and it has a nicer keyboard. I don't like to work on the Linux laptop because actually it's much less convenient. The screen is small. I usually like to work on the same computer for everything. Okay, same monitor, same keyboard, same mouse, so that basically I'm comfortable with them. I would like to work with everything using this setting. Okay, so basically I have the desktop, my desktop like this, okay, and I have my laptop basically. And what I do is I actually use RDP to log in to my laptop from my desktop so that I can have everything. I can have the screen here as if I'm working directly on this machine. This can be basically done, this protocol actually is a proprietary Microsoft protocol. It's not available on Linux, for example. So basically, if you have Windows, you can access such protocol. And basically, it would allow you to put the IP address. The IP address, as we mentioned before, basically, this would be assigned like 192.168.1.100, for example. And this is 192.168.1.101, for example, okay? So basically, I put this here, my computer here, and basically I log in with my credentials on this computer. It would allow me to do that. And basically, once I do that, I have my desktop, I have a window that has a desktop of this laptop on my desktop computer. So I can work here, but actually whatever I have here is running there. But it's very convenient, okay? Of course, on Linux, you can actually, basically, on Linux, we used to work on terminals. Terminals are, well beyond that. Basically, you can log in into any machine from your terminal, and basically, you would be working on that other machine. So, if I remember the work that I was doing at my university when I was doing my PhD, the lab was actually a set of terminals. And there were very powerful computers that we all log into. Okay, so basically we log in from these terminals to the very powerful computers that you have, which are very few. Okay, and basically whatever we are running is running actually on that very powerful computer. So basically this is very nice because you can actually pool the hardware resources into very few computers. And basically, if you want to upgrade, you're just going to upgrade a few computers rather than upgrading all the computers that you have in the lab. So for example, the lab used to have like 100 computers, 100 terminals, okay? The terminals don't have to have very high specs. The specifications of the terminals don't have to be really high. They are just meant to allow you to log into that powerful computer. And once you do that, you basically have that have that terminal working as if you are working on that powerful computer. So basically, this is very convenient. But this is actually because actually not working on Linux or Unix or Linux. Basically, this is available on Windows. And basically, if you have another computer and you want to log into that other computer from your preferred computer, if you prefer desktop, for example, this is a very nice way to do that. Okay, so basically you can log in from the RDP into a Windows computer or a Linux computer, but actually sometimes for the Windows computers, the Windows might need to be professional, Windows professional, not the Windows Home. Sometimes some of the services are not available on the Windows Professional. Okay. I personally actually used to ask what's the difference between professional and home versions of Windows, for example. But actually, when I started working with these things, I realized that some of the services, such as RDP, basically, I cannot basically log into a Windows computer unless this Windows computer is a professional version of Windows, has a professional Windows version rather than the home version. So basically, you might not be able to do that for the Windows, but for any Linux machine, you can do that. Okay. Sometimes if you have, for example, Raspberry Pi. Okay, Raspberry Pi actually runs on an operating system that is a variant of Linux. So basically, you can have your Raspberry Pi computer, Raspberry Pi board, for example, and you can log into that Raspberry Pi board from your desktop computer and basically work on your desktop. Basically, work on Raspberry Pi from your desktop. So this is really convenient if you want to do it like this. Because usually the problem with such systems as Raspberry Pi is that usually the displays that are used with Raspberry Pi are very small, and if you want to program or want to debug or want to whatever you want to do there, it's much less convenient to do on a very small monitor. If you want to, if you do it from this way, if you do it from your desktop, and from desktop you use the RDP to log into that Raspberry Pi board, you can actually work on your desktop or work on the Raspberry Pi from your desktop with the larger monitor and the keyboard and mouse and everything. Okay, so this is really convenient to use for such applications. This is kind of advanced because basically the regular users are basically unlikely to basically use it. Okay, so basically this is like for developers or people who are basically interested in Linux or do some research that actually runs on Linux rather than on Windows computer. So basically this is kind of advanced, but keep it in mind because sometime or someday you might need it. Whenever you want to set up a network, basically usually you have client connections. Okay, so basically it's like this. Basically it's like what we did on Packet Tracer. You might have desktop computers, you might have a server. For example, if you're talking about a hospital, you usually have multiple servers. and the multiple servers are connected basically to a certain router or a certain, usually the router has also access points. So basically this is a router slash access point, usually. Actually, the internet should go there. But actually, if you have the internet here, then the router is here. This is actually the architecture. The router is not here. The router is here now. And basically, you're connected the server, the desktop, and the access point to the internet. And then the access point, through the access point, basic access point means that this is wireless communication. This is a wireless device. You can connect anything else to the network through that access point. Okay, so basically, usually if you have a wired network, actually for any one of the computers that need to be connected to the network, you have to have a network interface card, definitely. Okay, and basically, usually you have to have, basically for the wired network, you have to have the RJ45 connection. This is the connection that basically allows the Ethernet cable to be inserted. And this is usually available on desktops and servers and things of that sort. And also sometimes it's available on laptops, but not as common in laptops, okay? They are definitely not available on cell phones or mobile phones, okay? So basically, this is for all, and this is for the wired network. You have to have that RJ45 connection, okay? Basically, the network interface card might actually basically be connected to a wireless interface. So basically, the network interface card, basically to the network, they appear as a network interface card. But actually, in the case of wireless devices, the network interface card doesn't have an RJ45 connection. Its connection is through wireless network. So basically, this is basically for the wireless devices. For the network hardware, usually you have to have an internet. This is actually done through a router. Basically, you have to have a modem. Basically, modem is a abbreviation for modulator, demodulator. Basically, this is what you connect to the, for example, the internet service provider like STC, for example, you connect through a modem. This modem is the interface between you, or basically your router, the router that you have, and the, for example, the optic fiber and the optic signal that are coming from STC. Okay, so basically you connect through that modem, and this modem takes the optical signals and converts them to electrical signals, and basically this is your connection to the internet. Then you have to have the router. The router basically is the device that is basically connects to the modem. Basically, it sends and receives signals from the modem. So basically, router creates the electrical signals, and basically it sends these electrical signals to the modem so that they can be transferred to the server or the internet service provider. And the same thing in reverse when you're receiving data from the internet. The router usually is configured to enable DHCP, basically, so that you can allow the different devices, whenever you connect a device, you don't have to think about an IP address for it. The DHCP server would actually assign each device a unique IP address and avoid any problems with IP conflicts. Okay, so basically this is very important. Usually it's very important. If you want to use static IP assignment, basically you have to be really careful. And basically, definitely at home you don't need to do that. The DHCP should be very good. It should be enough. And basically, if you have certain resources at the hospital, for example, if you're working at the hospital and you'd like to assign certain IP addresses for certain resources like printer, like image digitizer, like whatever, basically, then you might actually decide that you, for these particular devices, you might actually assign them a static IP address. But usually you have to plan it. Basically, the DHCP server, you can actually configure it to have a certain range of addresses. For example, I can say that the addresses start from 192.168.1.100 and go all the way to 150. So basically, I know that I can connect up to 50 or 51 devices, basically, because it's from 0 to 50, okay? And the range outside of that, so for example, if I have here 50, for example, here, or 55, let's just use another number so that it's not confusing. If I use here 61, for example, .61, this is available. If I use 159, it's available. So basically, I can assign the other devices that I would like them to have a static IP address. I can assign them addresses outside the range that is available to DHCP. So this range here is assigned to the devices. Whenever a device comes, basically it would get an address from the DHCP server, and basically it's somewhere in that range. If you want to have things outside, basically you can assign them manually, but you have to keep track of the IP addresses you have on your network so that you don't assign two devices the same IP address. The wireless access point basically can work in different modes. One of them is what's called ad hoc mode, which basically means that devices send and receive network traffic only between themselves. So basically, if you're talking about devices like this, basically you can communicate, communicate with each other, but they cannot communicate with anybody outside. If you're talking about infrastructure mode, then you can communicate between these devices, and you can actually access remote computers and the internet, which is actually what we usually like to have. Okay, if you do it this way, then basically both ways actually, this access point actually serves as a bridge between the wired and the wireless network. So basically, all these computers here are within the same local area network. So the access point acts as a bridge between the wired network and the wireless devices. So basically, this is actually one of the functions of the access point. It also acts as a base station for wireless network, where all wireless devices transmit to access point, which in turn redirects the signal to other wireless devices or internet. It means that if I wanted to communicate between these two computers, I don't communicate like this directly. I communicate with this, and then basically the access point would basically redirect my traffic to the laptop. So basically, this is the base station where everybody is communicating. Basically, all the computers here are communicating with that base station. Okay, so if I wanted to send something from here to here, I send it to the base station and basically, or the access point, and basically it forwards whatever I want to send to that laptop, basically wirelessly through the wireless network. They usually use antennas. Basically, these antennas actually they are very important. They are usually omnidirectional antennas, meaning that they transmit the same pattern everywhere. Basically, it's the opposite of omnidirectional is unidirectional, meaning that basically if I take basically a top view, for example, of the antenna, if it's omnidirectional, then the pattern would look like this. Basically, it's the same everywhere. If it's unidirectional, it would look like this, for example. It has certain area of sensitivity, but here you don't have any wireless connectivity. Okay, so usually they are omnidirectional, meaning that you would allow any device, or basically it doesn't matter where you are around it. Basically, it transmits the same way everywhere. Okay, so this is very important. It's very important to realize, basically, we need to connect the things that we talked about in cybersecurity with the access point security. Okay. Basically, if you're talking about the router that you have at home that you got from STC, it has inside, it has the modem, it has the router, and it has the access point all inside. Okay, so basically everything is inside the box that you got from STC. Okay, so it's very important to secure the access point in particular, because whatever you're sending is basically, anybody can basically listen to it. Okay, unless you have the traffic, the data traffic that you have for from or to the access point, if you don't have encryption added to the data while you're using that access point, then some people actually can just listen to that traffic and basically can get whatever information that you're sending, which is really dangerous actually. So unlike wired networks, wired networks are by default secure, because basically in order for a hacker to access a wired network, he has to actually gain physical access. And basically this is kind of difficult. Usually if you have a wired network at home, then he has to break in and basically access the data from your wired network, which is much more difficult than wireless. Basic wireless network can be accessed from outside of your home or outside of the hospital. Okay, so basically it's the cables are usually in the wall or buried underground or whatever. So basically it's very difficult to access. Wireless networks do not have these boundaries and hence are vulnerable targets for attackers. Okay, the attackers can easily intercept unencrypted wireless transmission and read private content and steal passwords or even change message. Meaning that basically, if you remember what we mentioned in the cybersecurity part, man in the middle actually works perfectly for wireless communication, because what it does is basically it can actually act as a middleman, and it takes the message from the first computer and it can change it and sends it basically to the second computer, and basically can modify things or can steal information, and this is extremely dangerous. Okay. One of the things that can be done actually is that for one of the problems in wireless communication is that if an attacker wants to just jam the network, he can do that. He can use what's called radio frequency jammers. They can flood the network with wireless data and bring it to crash. Okay. You have to remember that whatever we're sending things as signals that are in the air, and they are sent with a certain frequency. You're modulating that frequency so that you can send the information on top of it. So basically, if I have an antenna that sends exactly the same frequency, it would actually cause a problem, because basically you have, there will be an interference between these two signals, and basically this interference will cause the network to basically detect errors. Basically, whenever you're trying to detect the message, you have interference, you have very strong interference that basically causes errors in the transmission. If you have errors that keep repeating, basically either you will have a very slow network, because basically it has to send things multiple times in order for them to reach the destination without error, or basically you might actually cause the whole thing to crash, because basically it will not be able to detect correct messages through that wireless transmission. So basically this is one of the vulnerabilities that we have to actually worry about. Okay. Usually when you're trying to set up access point security, which is one of the things that we probably saw when we were working on packet tracer, you actually choose among different options like none. None means that I'm sending the information unencrypted, anybody can read it. WEP, WPA, PSK, TKIP, basically they are different technology. Basically these are different techniques of encryption, but they are basically encryptions. Basically, this is version 1 and this is version 2. There are several versions, basically. WEB actually was one of the earliest standard that people use, but actually they are considered now as less secure, because the encryption is not as strong as the other techniques. WPA became a little bit better, but actually WPA2 is way better than WPA. So basically, whenever you can, you should use WPA2. Okay. Whenever you set up the security options, you have to have basically you have to also enter SSID, okay, which is basically what you call a service set identifier. Service set identifier is basically the name of the network. Okay, so if you have your network called, for example, net1, for example, okay, this would appear here. Basically, you can change that to whatever you want. This is not a password. This is basically what people will see, okay, if you enable SSID broadcast. This means that if you're searching for a network, people will be able to see that, even if they don't have the username or password. or the password for that particular network, but they will be able to see it. If I uncheck this box here, then only people who know the name of the network will be able to access it. Okay, so basically you're making the life of hackers a little bit more difficult. Basically, they don't have the name of the network. They cannot detect the name of the network just by listening. That's it. Basically, like what you, if you go to a new place, for example, and search for wireless networks, you will see a set of wireless networks. If you uncheck this enable SSID broadcast, basically you'll not be able to see it, and basically this will make the probability of people targeting this network a little bit less. Okay, so basically this is very important. So first of all, the recommended setting is, first of all, you turn on Wi-Fi protected access to, which is WPA2. This is one of the very secure protocols. It has very good encryption. And basically try to disable the SSID broadcast, which is really good. You should place the antenna basically at the center of whatever place that you have, basically at home, for example. You don't want to put it near the window, because basically people outside will be basically able, the coverage of that network will extend a little bit beyond the home, and basically would allow people to access very good strength of this network from the outside. You don't want to do that. Okay, so you place it centrally inside the location that you have in order for the coverage outside of that area to be minimized. You should also, related to that, you should also reduce the power levels, basically. But actually, when you reduce the power levels, you reduce the coverage, because basically, if you have a very low power level, if you go a little bit further, you might actually have a problem accessing the network, or basically the speed of the network at remote places inside the location might not be as good. But actually, if you reduce the power levels while maintaining the coverage, that would be actually perfect. The one very important thing also is to create what's called a guest network. Okay, for example, inside the hospital, you basically have the hospital network that connects all the medical devices, the PACS system that you have, all the things that are basically related to the operation of the hospital, so the clinical operations of the hospital. Okay, this network actually should not be the same network that you allow your patients and their guests to access. So you should have another network that would allow such people, basically these people, to access, and basically you make it different so that if there is a malicious guest or somebody who is, for example, going in as a guest, but he's basically in reality a hacker, he will not be able to access the resources of the hospital, basically. So basically, it's better to create a guest network so that those people that you don't know, that are not related to the hospital staff, basically can access it, but basically this network is not related to the other network that you have for your devices. One of the things that I would like to point out also, what's called channel here. If you go to the wireless router at your home, you usually find this channel as auto. Basically, this channel means that if I talk about 5 megahertz, for example, okay, it's not all like 5 gigahertz. Okay, this is basically the basic transmission frequency. You actually, around that 5 gigahertz, you divide it into bands. Okay, each band is like, it's usually very small, actually. It's like few, maybe tens of kilohertz, for example. Okay, but each one of them, basically, you can transmit a different signal. Basically, you can decide that I'm going to use this for my wireless network, for example. Okay, or use that or whatever. So basically, you have a set of these. Because basically, if you imagine that you are living in a building, and basically if you're living in an apartment building, basically, and each one of the apartments has a different wireless router, if everybody is sending at the same frequency, then you will have interference between these routers. If my router and my neighbor's router are working exactly on the same frequency, then there will be interference between them, and basically the quality of the internet will be much less, or the quality of the network will be much less. So the best thing is to have it as O2. And O2, what O2 does is basically the router would, or the access point would actually search for the band that has lowest interference and uses that band. Okay, you have to be careful with that, because sometimes after a while, maybe your neighbor changed the wireless router, or basic another neighbor added a router that would actually work in exactly the same band that your router is working on, or your access point is working on. Okay, so basically, if you notice that the network is not as good at home, you might actually want to change the channel to another channel, or basically, if you change it to, for example, a certain number, usually have from I think from 0 to 15, something like 16 channels, something like that. If you change it to any number and go back to O2, usually it would detect another band that is basically, if there is a band that has interference, if your original band has interference, it would detect that and would choose another band, and this is usually the best way to go. So basically, if you notice that your network has interference, then if you select a different channel, or basically change it and change it to a particular channel and then change it back to O2, this will actually solve that problem. It's very important to be also able to troubleshoot your network. If you don't have internet, we all actually had that problem, basically. Sometimes you try to access the internet from your computer, and basically it tells you that there is no internet, okay? You'd like to know if this is from your computer, from your router, or from your ISP, from the internet service provider, okay? How can you debug that, okay? First of all, basically, first of all, the connectivity problems can actually happen from many different things, okay? It can be actually a result of cable problem. Basically, if you have a wired network, then the cable might have a problem. Or basically, if you have a network device, for example, if your laptop was dropped, for example, the network interface card might have a basic malfunction, certain malfunction. So basically, it can be basically the result of many things. So basically, you'd like to pinpoint where the problem is. Okay, so basically, it's when network fails, it's important to take a systematic approach to problem solving. Systematic approach means that you basically go one step at a time and basically try to debug where the problem is. Okay, so first of all, you examine the obvious solutions before more technical advanced areas. So basically, before you do anything, for example, you would check. If you have a wired network, for example, you check basically your internet cable, or basically if you have another cable, you can basically replace that cable with another, for example. Okay, so basically start to look for physical damage, for example, things of that sort. Okay, so usually start with the obvious things. The simplest causes are usually or in many cases actually might be the root cause of the problem. Okay, so if network loses connectivity to the internet, you have to first check that network devices like the router or access points are receiving power. Okay, sometimes for some reason maybe the power supply failed, maybe the whatever, sometimes actually if you draw more current from a certain outlet, it might actually trip if you have like a relay or something like that. If you have like sometimes you have some sort of a relay that would actually trip whenever you draw a large current, so that it protects the devices. So basically, you might actually check if there is power on that outlet, and basically check that the access point or the router is basically, if you have an on LED, for example, you make sure that it's lit. Okay. Another obvious check is to check whether the internet service provider may be experiencing network problems. Basically, usually you have, if you have one of the STC routers, for example, you have many LEDs. One of them is related to the received signal, for example. Okay, if the signal is low, basically instead of green here, you'll see red. Okay, so basically you want to check that. Okay, if you check all your devices and they seem okay, then basically you might actually start digging a little bit deeper. So basically use the ping command that we used before, and we tested actually on the command line on Windows. It's very easy to do actually. So basically you ping any website that you know, okay? And I would suggest that you try to ping a website like Google or Microsoft or whatever, okay? While you have a network. Okay, so that when you have a problem with the network, you know that you tried that before, and if you try ping to that particular website and it doesn't work, then you know that there is a problem with the network. Okay, usually if you send ping commands to 2 or more websites and it results in a problem with the basically you receive signals here, receive all the as I told you before, in the ping, we send a packet of data, and basically the server would send it back to us. Okay, so basically here you received the first, the second, the third, and the fourth. They are all there. So basically the connectivity is okay. If all of them are lost, and you try another website and they are all lost, then you might suspect that there is a problem with the internet, with your internet service provider. If you want to know exactly where the problem is, you use the trace RT that we use. It's trace route. It's called trace route, but it's actually written as trace RT on Windows. If you go to Linux, it's trace route. It's written as trace route. So basically, if you trace route from your location or from your computer to a certain website, okay, or a certain whatever, google.com, for example, okay, it will give you basically the route from your computer to that website. If you're trying to access a website and it doesn't work, you might try trace RT that website, the website you're trying to access. It will tell you exactly the route between your computer and that website. And if there is a problem in the middle, you would know exactly where that problem is. What we said before is that, if you remember the DNS protocol, we start with the local DNS, and basically we start going through different DNS servers so that we can actually know exactly the IP address of the server that we're trying to access, and then we're trying to access that through different routers. As we said before, the internet is a collection of routers, it's a network of routers. Okay, a network of routers, meaning that the information will have to go through many routers before you reach the destination, or before you get the information from the source that you're trying to access. So basically here you see the locations or the routers, the IP addresses of the routers between your computer and the final destination, okay? And if there is a problem, basically you will find that basically one of these places actually would be timed out. Okay, so basically this would tell you that the problem is at that certain location. If the problem is related to the internet service provider, then you would stop much earlier. Okay, if the problem is related to the web server, for example, if I'm trying to access a website, and the problem is that that website is down, so the web server for that website is down, then I can very easily actually detect that from traceroute. Okay, so this is really important. Okay, so basically here we can use ping, and here we can use traceroute, and these are very valuable tools actually to allow you to detect network problems. This is actually, you can use also, you don't have to use these actually for the internet. Basically, if you have a local area network, if you have, for example, a collection of monitors, patient monitors that are connected to your server, for example, and you notice that one of them is not connected. Basically, it gives you a message that there is a problem with the network. Okay, then you might actually debug with ping and traceroute to know exactly where the problem is. Okay, so basically you can debug local area network problems, and you can basically debug connection to the internet. Okay. One of the things that might happen, as we said before, is that basically if you have an IP conflict, okay? So basically, if you have an incorrect IP address, what we said before is that the local area network is defined by a range of IP addresses. Basically, you have basically what we said before as the what they call it here. Show it to you here, the subnet mask. Okay. This subnet mask actually would define how you define your LAN. Basically, the definition of your LAN is here at the subnet mask. Okay, so basically, if you have an incorrect IP address and you're unable to access the resources on your local area network, then you might actually need to use the IP config/all that we used before also to get that information here, and make sure that your address here, the address here is actually the correct address that it should be there. Okay, sometimes if you have static IP addresses, if you're assigning some of your devices as static IP addresses, you might actually get something like this. If you have an IP conflict, if you assign the same IP address to two devices, you'll get something like this if you are on Windows. Okay, so basically, this would mean that both devices are not going to be working properly. Okay, so basically, you make sure, basically, you try to make sure that your devices are assigned the correct IP addresses, and if there is an IP conflict that was detected, I need to change at least one of them to a different address so that you can basically resolve that conflict. Okay, so this is very important. Sometimes, by the way, the settings here, if you don't have the correct address of the router, for example, which is the gateway address, okay, which basically, if you don't have the correct gateway address, you will not be able to access the internet, for example. Okay, so this is very important. So if you look at this information, you look for the address itself, look for the subnet mask that defines the local area network. You look for the gateway address, which is default gateway here. Okay, and basically, if they are correct, then your device should work properly. If they are incorrect, if they are different from what you expect, then you should change them in the configuration of this device, and basically everything should work. Any questions? Okay, we actually have very few slides here, but actually what I would like to do now is I'm just going to go over the exam very quickly. Okay, and next time, inshallah, we're going to finish this these very few slides and start on the remaining topics of the course. So I'm going to share the exam now. Okay, this is the midterm exam here. Okay. For the first question here, which part of Hepa standard ensures that users are assigned appropriate security access level based on minimal data necessary to perform their jobs? Basically, this definition is for access authorization. Unique user identification doesn't actually talk about minimal data necessary, basically. We're talking about access level here. Unique users, they're just unique. I didn't basically assign them any levels, basically. They are just unique. Password management doesn't have anything to do with this. Code sets is basically related to how you're going to define the different diseases and different procedures. It has nothing to do with whatever we're doing here. So basically, the correct answer here is access authorization. What is the primary motivation for using electronic health records? Basically, you have different answers. The answer here is improvement of patient medical care. This is the most important one, basically. There are other things that might actually, you might actually think that they have something to do with the motivation for using electronic health records, but actually the core motivation is basically the patient medical care. This is the most important one. So basically this one here should be selected. Which of the following would ensure interoperability of a product with other products? Basically, we mentioned that there are a set of standards, but actually the certification is what guarantees that, okay? So basically, if I say that I'm HIPAA compliant or CHI compliant, actually this doesn't mean anything if I'm not certified, okay? The certification ensures all of these, okay? So basically, this is the main part. Basically, if the product is CCHIT certified, because this is the certification body. Like, for example, if you go to the Department of Motor Vehicles, for example, to get a driver's license, basically the driver's license is issued basically by an authority, and basically you will not recognize a person who says that I know how to drive without having a license to drive a car, basically. So basically this is the agency, and this is basically the one that should actually be there to make sure that the interoperability is there. The following would be considered as an advantage of EHR: efficiency, return on investment. We said that this is actually one of the disadvantages, basically, because it's unclear. Faster data entry than handwriting? Definitely not. It's usually handwriting is much faster. Involving no changes in clinical workflow? Definitely it hasn't changes, basically. So basic efficiency is the one that makes sense here. How should the web server also basically, actually this question, I'm thinking about actually adding the points of this question to everybody, because basically it talks about demilitarized zone. Basically we're going to cover it next time. So basically I think this is definitely the correct answer, but I'm not sure that we probably mentioned that in the cybersecurity part, but actually it wasn't as clear as the way we're going to mention it in the networking part. So basically this question will be considered as correct for everybody. So basically what I'm going to do is I'm going to go over the solution, the answers for everybody, and basically if you answer this question incorrectly, I would add the points to you. Or basically, I think the easiest way is just I'm going to add the points for this question to everybody, and that's it. Okay. So basically, if you solved it correctly, then I will give you an advantage. Okay. What is the terminology for a malware designed to replicate itself by independently exploiting vulnerabilities in networks? This is basically, this is the definition, the textbook definition of worms. Okay. The other ones don't really replicate themselves, and basically they are not related to the networks, basically. Each of the following attacks usually occurs much more often than other types of attacks. What we actually said that distributed denial of service is, or basically denial of service is more because basically it's very easy to do. It's much easier than the distributed denial of service. Okay, this is much stronger, but this is much more common. This is much easier to do. Basically, you can decide that I would like to do that today, and basically I will get a software from the internet and do it myself from my computer, just single computer, and this would be the easiest thing to do. Okay, so basically this is the easiest one to do. The other ones can be done definitely, but they would need a little bit more resources. Okay, spear phishing, for example, you need to get information about the person that you're targeting, and this is kind of it's not as easy. Okay, distributed denial of service, you have to have a really huge network of computers, the zombies that we talked about, and this is not an easy thing to come by, basically. Ransomware, they are not as common because actually they require people to basically you have to have the technology first of all to create the ransomware software, the actual virus. And the delivery method through email or website or whatever, it actually requires a little bit more work. So basically, the DOS is the correct answer. Which of the following devices is most vulnerable to cyber attacks when connected to the internet? We definitely mentioned the IoT devices because you cannot update them. Basic, all the other things here are usually updated. They are basic mobile phones, we basically get updates all the time. Same thing for Windows 10. Web servers are either running Windows 10 or Apache or whatever, usually get regular updates. So the IoT devices don't get the updates, the security updates, and therefore they might be vulnerable. If there is a vulnerability, it will remain there and people can still target it. What is the feature that discriminates spear phishing from regular phishing attacks? It's actually what we mentioned a few minutes ago. It's being highly targeted. Okay, this is the most important. What does two-factor authentication involve? Basically, you have a second token from physical or biometric source. Like, for example, if you're logging into your bank account, then it would actually get the username and password and then sends you something to your mobile phone. Okay, so basically, this is the correct answer. Which of the following may cause the greatest damage to a hostile network? What we said very clearly is that physical access, if you have physical access, you can do anything you want. Okay, so basically, all the other things might actually cause damage, but actually, physical access is the most dangerous. Okay, this is the greatest. Basically, you can burn down the whole network, for example. Okay, you can get a hammer or something like that and crush the server, for example. Basically, you can cause physical damage that is very difficult to repair. Okay, so physical access is the most dangerous. So basically, the physical security is very important in all computer systems. Basically. Which type of attack, where an attacker uses a brute force approach? Basically, a brute force approach is usually for password cracking. Okay, brute force means that you're trying all the options. Okay, the other thing don't really apply. You don't really use brute force in any one of the other ones. Which part of the CIA triad is targeted by the DOS attack? Denial of service basically access or basically targets availability, because basically when you have a denial of service, you're unable to access the service. The service is unavailable. So basically, this is the part of the CIA triad that is targeted by the DOS attack. What is considered an image manipulation? Basically, we have an image manipulation, and the other one was processing, basically. So basically, manipulation is basically if I wanted to zoom in, wanted to magnify, wanted to rotate, things of that sort. So basically, these are manipulation. Processing is more related to like basically you have something like you want to enhance the like, for example, the window level, you enhance the image, things of that sort. So basic image manipulation is more of basically zooming. Basically, is the image manipulation function, the only one that is considered an image manipulation function. Measurement and annotation, they are not manipulation. The image is still the same. I'm adding information to it.
دكتور الإجابات تقريبا كلها listed under the image manipulation and enhancement function حسب السلايدز، يعني ما كان فيها توضيح إنه كل واحدة إيش تتبع لها. حتى في الهوم وورك كانت نفس المشكلة، وحتى في الكتاب برضو راجعتها أنا نفس الإشكالية.
I will check it, but actually, if you go back to the lecture, I actually stated these the same way I stated them now. Okay, but I will check them. Okay.
Okay, thank you.
Which backed workstation function allows customized display of images on the screen? This is basically what we call the hanging protocol. Panning or navigation or query, they don't really address the customized display of images. So basically, the hanging protocol is like how you're going to hang the films in X-ray. So basically, this is related to how people will view the images. So basically, the hanging protocol here is the correct answer.
برضو هذا السؤال دكتور، الهانجينج بروتوكول موجود تحت النافيجيشن فانكشنز، بالتالي سبب لخبطه شويه. انا بالنسبه لي كنت فاهم انه الهانجينج بروتوكول از انستراكشنز، يعني ما هو
I will check it again. I'll check it. Okay. What does the term digitizer mean? Basically, we stated very clearly that this is the film scanner, basically, in the context of PACS. So basically, this should be very obvious, actually. What is the advantage of client server? Basically, one of the definite advantages is that only one person can open a study. So basically, you're not going to have the problem of multiple people accessing the same data, basically. So I'm basically reading the same image. So basically, you have a central work list, and the central work list would allow only one person to access a certain study. So basically, this is a different advantage. What is considered as a PACS reading station advanced function? Basically, if you look at what there was one slide actually that talks about the advanced function. The only one that has advanced function here is a multiplayer reconstruction. Zooming, annotation, and window level are basic functions. They are available everywhere. Advanced functions might not be available on all PACS workstations. So basically, this is the only correct answer. The true-false distributed system architecture in PACS involves using multiple archive servers distributed over different modalities. Definitely, this is different. This is incorrect. Okay, it basically we're talking about we don't have multiple archive servers. We have only one archive server, but actually, the relationship between the reading workstation and the modalities, they are directly connected. They are not connected through the server as the client server architecture. So basically, this is false. PACS receives patient images using interface with the radiology information system and hospital information system. Basically, we're talking about images here, not the information of the patient information. RIS and HIS don't have images. Images are in PACS, in the archive server part of PACS. So basically, this is incorrect. RAID 1 technology is used to enhance speed and reliability. We actually, if you look at the slide, actually you find that this is.
دكتور بالنسبة للمصطلحين الثانية اللي هي ال HIS والثاني اللي هو RIS أظن.
HIS and RIS. Yes.
ايوه المشكلة انه ما عندنا معلومات كافية عنها فبالتالي الأسئلة اللي تخصها.
We talked about PACS. We mentioned RIS. Basically, we mentioned HIS is the one that has the EHR. Okay, there was a block diagram that actually showed HIS and RIS. And what we mentioned about the RIS was that this is basically the appointments, basically the scheduling and things of that sort. Both of them are related to the schedule. So basically, what you should focus on here is that the images are not on any other system but the PACS itself. The images are on the archive server of PACS. So basically, they don't receive the images from any other system in the hospital, basically. They get the images directly from the modalities and they store them on the archive server, and basically it's all inside the PACS itself. So this is definitely incorrect. We mentioned that already. It enhances speed and reliability. RAID 1 actually would allow basically both the speed and reliability to be improved. This was one of the things that confused several of you. This was actually a typo there. So basically, wet imagers offer lower quality films than dry imagers. This is definitely false because basically the higher quality is with wet imagers, but the problems of wet imagers are related to the way they are used, the chemicals and installation and things of that sort. Dry imagers are more common because they are easier to install than wet imagers. This is definitely true. Interfacing PACS, HIS, or RIS usually involves sharing data and processing functions to all systems. Actually, this is incorrect because basically you share only these things with the reading workstations. Okay. Rootkits independently replicate themselves by exploiting operating system backdoor. This is actually not the way this works. Basically, they don't replicate themselves. They would allow a backdoor to be created, and basically through that backdoor, people can access that system, but they don't replicate themselves. To guarantee that the recovery of deleted files will never be possible, you may need to physically destroy the storage device. Basically, if you work for the mob, if you work for the mafia, for example, okay, you don't want to have a storage device that has your information, okay? If you work on like a national security, things of that sort, and you want to replace your hard drive, you don't really give it to your younger brother or something like that. You never do that, okay? You have to actually physically destroy it, okay? This is the only way you guarantee that nobody will be able to recover the deleted files. This is one of the things that we actually emphasize. The cybersecurity professional is allowed to do things that are considered illegal for others in order to defend the organization from hackers, okay? Basically, the cybersecurity professional cannot do anything illegal, basically. Anything, the difference between the cybersecurity professional and the hacker is that the cybersecurity professional works within the bounds of the law. If they go beyond the bounds of the law, basically, they are not any different from hackers. Okay, so basically, cybersecurity professionals are not allowed to do anything illegal. Hepa standards are included among the optional standards. Actually, this is not an optional standard, okay? Consolidated Health Informatics, the CHI standards, are not a set of optional standards, they are a set of mandatory standards, okay? They are different standards, but actually, it's mandatory to abide by all of them. So basically, it's not optional. The resistance from hospital administrators to implementing EHR in their hospitals is mainly due to unknown impact on patient safety. Actually, this is definitely not the case. They have problems with the return on investment, things of that sort, but they are definitely sure that EHR is better for patient safety. This is basic, there's no doubt about that. So this is definitely false. The account of disclosures of protected information was first introduced in Hepa standards. This is actually true. The main difference between encryption and hashing is that the hashing is irreversible. This is definitely true. Encryption, you can reverse it. You can encrypt and decrypt, but hashing is irreversible. The distributed denial of service attack originates from multiple coordinated sources. This is actually the definition of DDoS. Performing technically legal actions require following ethical guidelines. This is definitely not the case. This is actually one of the issues that we talked about. Some things that might be legal are unethical. Okay, so basically you have to basically try to abide by the ethical guidelines that are provided by the societies that basically work in the areas of information technology. And basically, it's not enough to just be legal, okay? PHI is an acronym for Protected Health Information. This is definitely true. Physician review station is different from quality control station because of the need for medical grade monitors. We mentioned that we need the medical grade monitor only for the radiologist workstation, okay? For the viewing workstation. The physician actually has a regular monitor and the quality control station has a regular monitor. So basically the difference between these two is not related to the monitor. Accountability for intentional or unintentional disclosures and modifications to protected health information can be accomplished by tracking user access. Okay, this is definitely true. Basically you know exactly who accessed that information and you hold them accountable for that. We went over everything. If you have certain points that you'd like to basically object to, if you're basically you solve the problem in a certain way and you would like to change your grade or something like that, please send me your feedback. Okay, if there are any questions like the question that you mentioned that were mentioned in the lectures in a certain way that confused you, please also send me this information so that I can know that and I can try to think about it and see if it's justifiable to give you at least a partial credit for any questions you did wrong. Okay. Any other questions?
يعني تكرما لو مثلا بداية المحاضرة الجاية أو كذا تشرح مثلا الانترفيس بين الباكس والاتش اي اس
اوكي ان شاء الله.
مش فاكر الثالث يمكن.
هو كده كده it's a part of HIS and RIS, okay, but actually I'm going to show you the part of PACS that actually talked about this, okay?
طيب اوكي.
Okay. Any other questions? I'm sorry we actually took a little bit more time, but actually started a little bit late, but hopefully inshallah next week will be on our regular times. In Ramadan inshallah we expect a different timing from the university, so basically whenever that timing is announced by the university, we have to discuss it together so that we make sure that it's okay for all of you. Okay, if you want to change it to another time, I'm flexible basically inshallah. Okay,
Doctor?
so I'll see you inshallah next time. Yes.
Can you extend the deadline of the project number 3?
Don't worry about that. Submit, whenever you want. Okay. Don't worry about that. Yeah. Basically, it's gonna appear on Blackboard as late, but I'm not gonna deduct any points. Okay.
Thank you, Doctor.
Okay. Good luck, inshallah. Okay. So I'll see you inshallah next week. Inshallah. Assalamu alaikum.